The James Webb Space Telescope has captured something that has left scientists and space enthusiasts in awe. Unusual lights appeared to shine from a point about 4 light-years away, sparking intense discussions around what could be the source. These lights seemed eerily similar to those emitted by cities here on Earth, creating speculation about whether we may be observing evidence of alien civilization. The telescope was focusing on Proxima Centauri b, the closest known exoplanet to our solar system. While observing the dark side of the planet, it detected bright, rhythmic flashes. These flashes didn't match any natural cosmic activity we usually recognize, prompting scientists to wonder, could this be artificial light? Something created by intelligent beings? This isn't the first time people have dreamed of life beyond Earth, but this moment has reignited that hope. Scientists have long believed that if intelligent extraterrestrial life exists, we might detect them not through words or messages, but through their technology or energy use. And this could be what's happening now. Dr. David Kipping, an astronomer at Columbia University, noted that Proxima Centauri b is a complex planet. Unlike most rocky planets, it doesn't just absorb sunlight and release heat in a predictable pattern. Instead, its interaction with its star, Proxima Centauri, creates unusual thermal behaviors that make it even more intriguing to study. The James Webb Space Telescope, often misheard as James Wood, plays a key role here. Its infrared imaging capabilities allow it to observe what other telescopes might miss, especially in the pitch-black environments of space. It can detect subtle variations in heat and light, which makes it perfect for studying a planet like Proxima b. Infrared light is vital in space exploration because it's often the only way to detect what's happening in the shadowy regions of a distant planet. On Proxima b, the light captured might not just be reflections from its star. It could be something more, something artificial. Scientists are investigating whether this light fits within the narrow frequency band associated with artificial lighting, far narrower than starlight. Proxima b is in the habitable zone of its star, meaning it might have conditions where liquid water could exist. It also rotates in a way that gives it day and night cycles, much like Earth. This would be important for maintaining temperatures suitable for life if it has an atmosphere. Without an atmosphere, however, the planet would have drastic temperature swings. The daytime side could be scorching hot while the night side could freeze. But if an atmosphere is present, it could moderate these differences, making the planet more habitable. The light captured on the night side could even be from cities powered by alien technologies, if such life exists. The Webb telescope's ability to detect thermal emissions provides insight into whether Proxima b has an atmosphere and what it's made of. Detecting oxygen, methane, or water vapor would be a significant sign. These are biosignatures, chemical signs of life. Even the presence of ozone can indicate biological activity. Yet, the telescope has limits. It wasn't designed solely for detecting signs of life. While it can pick up signals of water vapor and carbon dioxide, spotting free oxygen is more difficult. Still, scientists remain hopeful because other indicators can also point to habitability. Dr. Lisa Kaltenegger, an expert on exoplanet habitability, said, "If we find just one exoplanet with a breathable atmosphere and life-supporting elements, it would change everything we know about the universe and our place in it." Despite its brilliance, the Webb telescope can observe only a limited number of nearby exoplanets. For more in-depth studies, researchers are looking ahead to future tools like the Extremely Large Telescope, ELT, scheduled to start operations by 2028. The ELT will offer higher resolution and more detailed atmospheric data, potentially revealing much more than we can see now. Dr. Sarah Seeger, a leading exoplanet scientist, says, "These new instruments are giving us eyes sharp enough to actually detect alien weather and possibly even alien vegetation." That may sound like science fiction, but with current advancements, it's edging closer to reality. As technology advances, so do our strategies. Scientists are working on starlight blocking techniques to better observe exoplanets. Stars are so bright that they can drown out the light from nearby planets, making it incredibly hard to study them. To fix this, researchers are developing tools like coronagraphs, which block starlight from within the telescope. Another exciting technology is the star shade. This is a giant, flower-shaped spacecraft that flies in sync with the telescope. It blocks the star's light before it even hits the lens, allowing only the planet's faint glow to be captured. This could make it possible to directly image distant worlds, even see their landscapes, weather, and maybe even lights. However, this work is very challenging. Aligning a star shade tens of thousands of kilometers away with extreme precision is not easy. The spacecraft has to stay in sync within fractions of a millimeter. It's one of the most difficult engineering challenges of modern astronomy. Still, the payoff could be historic. Imagine clearly viewing a planet 4 light-years away and discovering patterns of light that change over time, resembling power grids or traffic movement. That's what scientists are preparing for, direct imaging of alien civilizations. Researchers are also improving adaptive optics, which help counter the distortion caused by Earth's atmosphere or telescope movement. Combined with light-blocking tools, they might enable telescopes to not only detect exoplanets but also map their surfaces and study their climates. These developments bring us closer to solving the question, are we alone? This question has haunted humanity for centuries. Now, we are finally building the tools to answer it with real data. Even though we haven't confirmed life yet, every piece of evidence, like the strange lights on Proxima b, keeps adding to the case. Each discovery nudges us closer. Even small details, like the planet's chemical balance, heat emissions, or seasonal changes, tell stories about what might be going on there. Many scientists believe that life elsewhere is statistically probable. With billions of stars in the Milky Way and possibly even more planets, the odds that Earth is the only one with life seem slim. Dr. Jill Tarter, a leading voice in the search for extraterrestrial intelligence, has said, absence of evidence is not evidence of absence. In other words, just because we haven't found it yet doesn't mean it's not there. Some believe we might already be seeing signs but lack the technology to fully interpret them. The mystery of those lights on Proxima b could one day be seen as the first clue, the spark that led us to a breakthrough in cosmic discovery. As of now, scientific teams continue to monitor Proxima b, analyzing the data captured, refining their models, and planning more advanced missions. The next generation of space telescopes may even be able to detect alien agriculture, pollution, or energy use, all of which would be unmistakable indicators of intelligent life. The search isn't just about aliens. It's also about understanding ourselves, our planet, and our place in the vast universe. Each mission, each new telescope, expands our vision and reshapes what we believe is possible. So, what will we find next? Maybe the lights on Proxima b are just strange geological or atmospheric events. Or maybe, just maybe, we've glimpsed the distant glow of a civilization that has been watching the stars too, wondering if they're alone. Subscribe to our channel and thanks for watching.